Hey everybody, Lonnie here again, working on the Backyard Browser application, and hopefully you've been following along and things are going well for you and you're not encountering too many problems. So this is the end-to-end example of using OSIsoft's OSIsoft Cloud Services, OCS, and this is part 8. We're working on the API, and now we're going to go ahead and grab that forecast data. We just finished getting the snapshot values, and we're going to reuse a lot of that code and set it up. This should be pretty quick video, not too complicated. We'll do a little bit of refinement along the way. Looking at our architecture, just to review that real quick, we know that the top part is complete. Our data is going into our sequential data store now from our weather station and the forecasting service. We're now reading the data store with the API, which is going to be a couple of Azure functions. We've already created one, and we're going to create our second one. And that is setting the data up, getting all formatted into a JSON payload that's going to be sent out to the front-end application that'll be written in Angular. So Angular will be making these requests back to the API, and that Angular application will actually never directly make a request to the sequential data store. That'll always happen through this API. I typically like to do that type of architecture because that allows you to do a lot of things at the API level if you need to read in other data sources, maybe not just a time series database like the sequential data store, but if you need to maybe query a SQL database or something else, you can do that at the API level. So it just gives you a lot of flexibility as far as a real world application goes. Okay, so let's go ahead and switch over to our application and get started. So here's our get snapshots HTTP call, and what I want to do here before we move into getting the forecast call, I want to do something. I want to bring in our location ID. If you look at our if you look at our get snapshot async here, you can see that we have this hard-coded weather station name and location, and then we have snapshot. So we know the snapshot will always be there. That's built into how we're reading the data. That's like by convention, we're going to always use snapshot. But I do think this could vary depending on what weather station you're trying to find. So let's go ahead and get this out of here, and this will come. I want to have this request that that information sent from the front end application when it wants data for our weather station. That'll set us up if we add multiple weather stations later on. We can just change the name of the weather station and we'll be good. So let's go ahead and call this string location ID, and in here we'll get rid of our that and just put this in location ID. Okay, and then coming back to our get snapshots, here we're going to pass in a location ID, but first we need to go ahead and get that from the request. So there's so we can check to see, first of all, is the location ID actually there or not. So we can examine the request. Well, let's go ahead and set up our key. This is going to be called location ID. And then let's go ahead and examine our key, and we can do this in an if statement. So if our request query, if that contains a key and the key is going to be called location ID, then we can go ahead and do the rest of this this operation here. Else, if that doesn't happen, then we probably just need to do something like return new bad request object, and we can put in here location ID not contained and request. And here we need to actually get the location ID from our request and then pass it in. So we can just do request query, and then we can pass in the key that we're looking for. We know that key exists now. So that'll allow, now we can pass in the napa.pluto, and we should be able to get back our information. Let's try running. Should be able to get back the data. Let's try running this and make sure that works. Let's go over to the browser. escape out of this, come back to this call here. We don't have a location ID, so location ID is not contained in a request. That's perfect. Now we can go ahead and we can say location ID, and we can we don't put this in quotes, so it's going to be Napa Pluto, and we'll do that, and we'll send that in, and now you can see we're getting our data, so that's perfect. Back to our application here, stop it. Now we want to move into creating our get forecast. So go ahead and copy this and rename this to get forecast. And the forecast, just call it, whoops. Change the names to protect the innocent. And then down here, we'll create this. We don't have this yet, so it's not gonna, IntelliSense isn't gonna work, and it's gonna not like us. But otherwise, you know, this is all going to be the same, right? We're not going to have to do anything different here. We're gonna at the end of the day, we're going to be returning this this J object, just like we did with get snapshots. So so we have that. Let's come back to our API here, and we have our get snapshots async, and we're going to have a similar method here, but we're going to reuse most of this code. So what we'll do, let's just stub out, let's just stub this out. And by stub out, I mean we'll do this, and this would be get forecast, and we know that we're going to have code contained in here. But we can return a null just so that we don't have any errors. And then we can come over here to get forecast, and that's all happy. Okay, everybody's happy. So what I want to do is we're going to do a similar call. This call here is going to be getting our current data, and then we're going to have to do a second call that will get our daily data. So I'm going to switch back to our slides, and if we look at getting our forecast data, this is what the JSON payload is going to look like. So we have current, and then we have time, summary, and icon. If you notice these two, their values are string, so we're going to have to kind of deal with strings now, because we only had to deal with doubles before, so there'd be a new type for us to handle. There's no UOMs associated with that, so that's kind of makes it pretty easy. The time is the same situation that we had with our snapshot. And then the daily, we're going to have an array, and in that array, we're going to have a similar structure that we have like the current. We have the time, then we're going to have a summary, and these are going to have various values, and we'll be going through all of those, but we're going to put this in an array. Let's come back to our application now and take a look at how we're going to approach this. Okay, so here's our snapshot code. We want to reuse most of this, I think, from this point here. So this is getting our, so this gets data from OCS, and then this below here, we're converting the data to JSON, and so pretty much everything that we come down to here is all, well, the results is actually a J object, so we'll say all of this code is going to become our new, a new method for us. So let's call this static. This will be async because we do make some calls in here for the UOMs. And then, so we want to return a J object, and let's call this convert to J object async. And we're going to pass in some data. And in this case, we were passing in weather station object, but this could be our forecasting objects too, so we need to make this generic. And we'll call this data. All right. Put this inside a try catch block because it could fail when we're making our calls to the sequential data store. And then I'll paste in that code that we just brought in, that I pulled from the other method. Okay, and if we look at, put in our exception here. All right. Okay, now how does this convert over? We have our data, everything actually looks pretty happy, and then we're returning our results as our JObject. So now we can just make our call here, and we can say await, and we'll do our convert, and we'll pass in our data. And we should be good. So this really can be completely reused for our async, and we just need to change our type from forecast weather station to whatever the type is. If we remember, under forecast here, we have two types, right? We have our forecast current, and that contains some strings, so we're going to have to deal with those. And then we have our forecast daily, and everything's coming back, or everything's stored in the sequential data store as those two types, but one's a collection. Okay, so we want to get the last value of the forecast current, just like we did with our snapshots. So let's come back to our API, and this is going to be forecast current. Forecast current. Location ID is fine, but we do need to change this to forecast, and this is current. That'll bring that data in. That's going to serialize it, and then we're going to end up the time will work fine, but here if we look, we're expecting these to be doubles, and that's not going to work for us. So we need to do another check here to see if we have a property that has that we need to check the property type, I think, to make sure that it's not a double, that if it's a string, then we can do our conversion here. So we can do an else if, and we can say property dot, and we can get the property type name, and if that is equal to string, then we can go ahead and do a conversion here. And we know we don't have to worry about unit of measures if there's a string, so we can just take our we still want to create our object here, but we really just need to do these two, and instead of this conversion, we can just come over and we can just make this to string, right? And now we have our value set up, but we do need to make sure that we add it, just like we did down here. We want to make sure we add that to the overall object. Okay, and so I think this is probably at a point where we can give it a shot. So we should just see our timestamp, and we should see our string values if this is all working right. Let's try it. Okay, so now we have, if you can see, we have our new call here, get forecast. So let's come back to our browser here, and let's change this to get forecast. All right, so all that code that we hammered out, the last part, is really paying off right now. Time looks good. You can see all the characters, all the first letters are dropped just like we want. And we have our summary, we have our icon, and we have our daily summary, exactly what we want it to look, exactly what we want it to be. Now we do need to have this overall. This needs to be in an object in itself that says current, and that needs to be contained in here, because then we're going to have a J array called data. If you come back, if we look if we look here, we have this current J object, and then we have our daily J array. So let's go ahead and get our current J object situated there. We can stop our application, come up to our, so here's our data here, and we can, we've converted it. This is a J object, so we can say, we can go, we can do var current, and that's going to equal to that. So this is going to be a J object here. But our overall results, let's go ahead and do this. Results, let's return that, and let's create a results object up at the top here. And we can go, var, that is going to equal a new J object. And here, we probably don't even need to create this. I think we can just do this, results, and we can call this current. And that can equal that J object, okay? All right, now, so this is going to be, it's our current forecast. And now we want to go ahead and we want to do something similar here, except we're going to have to go through, we're going to have to work with this array here. So let's go ahead and get our data first. And to get the data, this get last values async isn't going to work because we actually have a time range now that we're working with, right? We're talking about the moment that we make this, the moment that we're in now to 7 days, 7 days out. Okay, if we come over to our documentation, I'm going to look under reading the data API, and then we're looking at get values here because we want to return multiple values. And in here we have a few different options, and windowed is the one that I want to work with here. It returns a collection of stored events based on a specified start and end index. And then there's also this boundary type that we want to pull in. I want to make sure that I'm not including anything outside the boundary. I just want to include if it's on the boundary or if it's within. And so this is the call that we'll be using. And if we come down at the bottom here, I believe we see a .NET call here. And the one that I'm going to be passing in is this, get values async, and we'll be passing in the start and index, and we'll also be passing in the boundary type. If you've ever worked with PyData, you know exactly what we're talking about here because this happens all the time. It's no different here with OCS. So here we'll do var data, and we're going, or this will be var daily data, and we'll call this C data here for current data, just so that we're being consistent. And we'll do an await. Await operation using our SDS helper, and we're going to use the data service, and we're going to get windowed values async, and we're going to pass in here our forecast daily, and then we're going to pass in some data here. Whoops, pass in some data. So we need to pass in the stream ID, which will be pretty much what we have up there. So location ID, but we'll do .forecast .daily, right? And then we need to pass in a start index. So the start index, if you remember on the C data, we on our current data, we actually have a timestamp. If we come over and we look at forecast here, we have this timestamp, and this is the current time that we make the call. So we can grab that. So we know what our basically the last time the forecast was updated. We know what that time was, and that's the time that we want to use to start our forecast going forward, because the forecast information keeps getting updated, but once it moves into the past, there's data in the past. We actually still retain our last forecast information that was populated. So we can always, if we ever wanted to, we'd always back and see how well the most recent forecast compared against actual, which is kind of cool. Okay, so but we can use that timestamp here with our C data. So let me come back to our file here, and we can go C data, and we can get our time here and convert that to a string. And then we can take our C data time, and we can add days. I'm going to go ahead and add 8 days just to make sure I get all the data. And then we'll go ahead and convert that to string. Okay, and then the last thing is we want to do our boundary type. So there's the boundary type, and we want to make that exact. So that just means that if there's a value that is actually exactly on the boundary for by chance, then we're going to go ahead and use that. Otherwise, we're only going to use the one that's the next one that's going to be in that range. We're not going to be ever looking outside of the range. So we'll make exact. And then put a semicolon. And I think we're good here. So there's our data. Now we need to go ahead and we need to loop through the data and create another a J array. So let's go ahead and get our J array. So we'll call this and that'll be a new J array. Okay, and then we'll do a for each loop, and we'll do item, and we'll do this our daily data. And now the item is going to be cast to the forecast daily. Now we can go ahead and get the J object back and add that to our daily array. So we can do daily, we can add this, and we can do a we're gonna have to do an await, and we'll do a convert, and convert to, let's get that IntelliSense working, convert to J object async, and then we'll pass in this item data. And that'll take that object, add it to the J array, and then once we're done with that, we need to just take our results outer object, and we need to do our daily property, and we'll set that equal to our J array, J daily. And yep, data from OCS, and then we will convert to JSON. And we'll say here, convert to JSON. Okay, perfect. I believe if we look at our forecasting data, we have strings, we have doubles, we have unit of measures. So everything should be taken care of. Let's go ahead and try running it. Come over to the browser here, and let's go back to the browser. Let's try refreshing this and see what we get. Okay, so now we have our current object, and you can see that's now nested here. That's perfect. And then our daily, we have the daily, we have our time, and we can see that's the 18th, 19th, 20th. We go all the way out to the 24th. So, and then we have, these are just all repetition. We have some strings in here. We have some unit of measures. We're making, we're getting all these values. Everything looks perfect. That's great. The one thing I should mention here on this is that, you know, we're making this call in the API. We're making a call to unit of measures. We're doing this call here to get from metadata. So every time we get a value, we make a call to get a unit measure. What I'd probably do if this was more of a production app is I'd probably try to hold this in memory. So the first call, I would get the unit of measure, but then I would just check a dictionary, see if the unit of measure was in the dictionary. If it was, then I would just use that versus keep making repetitive calls, because they're making 2 calls every time to get a value and to get it when there's a unit of measure to get the unit of measure. And that's kind of for performance, that's not great. So it'd be simple to do that, but I'm not going to get into that. Otherwise, the video would last forever. All right, so that really concludes the API part. The only thing that's left to do with this API is to deploy it to Azure as Azure Functions, and then we can make the calls from our front end to to the API endpoint. So stay tuned for the next part, and we'll go ahead and take care of that, and then we'll get into designing the front end with our Angular app, which is going to be a lot of fun. All right, my name's Lonnie. Thanks for watching. I'll talk to you later. Bye-bye.